Hey class, Key Allen, I'll be going over an informative essay on to inform you on cryogenics. So this speech is going to be about cryogenics, and cryogenics is the science of producing and studying low temperature conditions. The word cryogenics comes from the Greek word in cryos, meaning cold, combined with the shortened word, the shortened word of English word to generate. It comes to the meaning of generating temperatures well below those a normal human experience. So the origin of cryogenics as a scientific discipline coincided with the discovery by the 19th century scientists that permanent gases can liquefy at exceedingly low temperatures. Consequently, the term cryogenic applies to temperatures from approximately negative 100 degrees Celsius um, down to absolute zero, which is the coldest point a material could reach. So the central idea of cryogenics is the process of it. So people must be vertified. First, the body is placed in an ice water bath. Then, ice-resistant chemicals are pumped into the body, taking place of the water in the blood. That way, in the next step, when the body or brain is cooled too well below freezing using nitrogen gas, it hardens without forming cell-damaging ice. So when you hear the term cryogenics, what do you guys typically think of?
Cold, freezing, cryogenics.
Yeah, right. So most people think of genetics, which is a general misconception. But today I'm going to help you decode this word so you have a better understanding of what cryogenics mean and what its purpose is in human health. So I've conducted extensive research and have a personal interest in the subject of cryogenics. And today I will inform you on the history of the cryogenics, the process of the cryogenics, and how the vitrification process of cryogenics works to preserve a human body. So here I'm going to start off with my visual aid, ice cubes. So similar to vitrifying the body, they induce the ice-resistant chemicals. So similarly to ice, uh, water is cooled, frozen down, so the solid molecules. So the molecules become solid, therefore leading to ice. So it's kind of similar to the vitrification process where it's pumped with ice-resistant chemicals so that it can slow down the molecules in the body, producing less heat, freezing them, and then preserving the human body. So moving on. Cryogenics was developed in the 19th century as a result of efforts by scientists to liquefy the permanent gases. And one of the most successful scientists who did this was an English physicist named Michael Faraday. Um, by 1845, Faraday had managed to liquefy most of the permanent gases that were known to exist. His procedure consisted of cooling the gas by immersing in a bath of ether and dry ice, then pressurizing the gas until the unit liquefied. Moving on, cryogenic temperatures are usually described in the absolute or Kelvin scale, in which absolute zero is written as 0 Kelvin, without the degree sign, as we most commonly see. Cryogenics has a beginning in 1877, the year that oxygen was first cooled, at which the point it became liquid at negative 180 degrees Celsius or 90 degrees Kelvin. This was done by Louis Calliot in 1832 in France, and the Royal Pictet in 1846. So the origin of cryogenics as a scientific discipline coincided with the discovery of the 19th century scientists that the permanent gases can be liquefied at T1 temperatures. The temperature of any material, solid, liquid, or gas, is a measure of the energy it contains. The energy is due to various forms of the motion among the atoms or molecules in which the material is made. So, being that a gas consists of very rapidly moving molecules, for example, higher the temperature than one molecule that are moving more slowly. So in 1848, English physicist William Thomson, later known as Lord Kelvin, in 1824, pointed out the possibility of having a material in which particles had ceased all forms of motion, then the absence of all forms will result in a complete absence in heat and temperature. So then Thomas defined this condition as absolute zero. Subsequently, the vitrification process has been used to effectively preserve blood, stem cells, and semen. Although restoring the life of a vitrified human or to an organ as complex as the brain remains an unfathomably distant prospect. Uh, it is divided on cryonics, which is a scientific community. It's between neuroscientists willing to state that reanimation is at least within the realm of physical possibility, and those who believe it so, it's unlikely that selling even the hope is unethical. So after hours of information theoretic death, you are injected with the solvent dimethyl sulfoxide and attempt to stave off tissue damage. Next, the body is packed into a styrofoam box of dry ice, then eventually submerged in liquid nitrogen. And the evidence here is kind of like a fun fact if you didn't know. Mr. Bedford, James Bedford, he's been seen only once in the last 50 years after he's been vitrified and preserved in Alcor in Scottsdale, Arizona. He's been in Alcor since 1991. He's actually the first person to submit his body to the cryogenics process, and he's been vitrified over 50 years now. Another 3,000 people are still living and arrange themselves to join the cryonics called deanimation, in other words, death. So today you learn about the cryogenics process and its history, as well as the actual vitrification process and how it's stated cryonically, how it started cryonically to preserve a body. This process can only happen after information theoretic death, like I just stated, in other words, legal death. So, as previously stated, the first body is placed in ice bath, then ice-resistant chemicals are pumped into the body, then moving on to the nitrogen gas freezing the body without harming the cells. So, all of this process means to be indefinitely frozen and stored indefinitely. It hopes that technology will arrive to you in the future. Also, that a future cells will one day exist to make this a reality. All right, class, thank you.